I'm going to carry on with the second part of this question. The probability that a defendant who is brought to trial is guilty is T. The king pronounces that the defendant is guilty if at least 2 of the judges give a guilty verdict, otherwise he pronounces the defendant not guilty. Find the value of T such that the probability that the king pronounces correctly is a half. Okay, so let K equal king is correct. Okay, so K is equal to the probability that the defendant is guilty times the probability that the judges give 2 or more guilty verdicts, which is x2 from before plus x3. Just to remind you, x2 and x3 were defined as probability that judges give 2 or more verdicts and 3 or more 2 verdicts and 3 verdicts. So x2 plus x3 is the probability of giving 2 or more verdicts. Then plus 1 minus t, which is the probability that the defendant is innocent, plus x1 plus x2, which is pretty much the probability that the king says that the person is innocent. Okay, that's kind of clear. Note that 1 minus k, which is the probability that the king is wrong, is what the probability that he's innocent and that x2 plus x3 that he's guilty, plus the probability that he is the probability that he's innocent times the probability that the king says he's guilty, plus the probability that he's guilty times the probability that the king says he's innocent. Okay, that is the probability that the king is wrong. Now we want k equal to a half. If k equal to half, 1 minus k equals k. So these two expressions here are equal to each other, so we can say t x2 plus x3 plus 1 minus t x1 plus x2 equals 1 minus 2 t x2 plus x3 plus t x1 plus x2. Okay, this rearranges. We're going to try and put the t's all on one side to t x2 plus x3 plus another one, so 2 x2 plus x3 minus an x1 and an x2 and then another one, so the 2 x1 minus x2. Okay, then on this side we're left with this equaling x2 plus x3 minus another x1 minus x2. Now we've got a common fact here of this bunch of stuff. Can this ever be 0? Because if it can't ever be 0, or if it's not in this case, because remember this is really talking about it in the general case before we put those values of p in, but these things have actual values, and therefore this is actually 0 or it's not. To check though, essentially we're going to have to check that it's not. The numbers are messy however you do this, but we're going to try and make them slightly easier by noticing that these are kind of mutually exclusive. So x1 plus x0 is also equal to 1 minus x2 plus x3. So we can also write this as 2t 2 x2 plus x3 minus 1 equals 2 x2 plus x3 minus 1. So clearly, if x2 plus x3 equal a half, this is going to be 0. What is x2 plus x3? Well, x2 plus x3 equals... Now we had p equals 2 thirds. P over 3, therefore equals 2 over 9. And p squared equals 4 over 9. Now I'm going to quickly do this, but hopefully you can see what I'm doing. x2 is going to be p 2 thirds times p over 3, 2/9, times 1 minus this, which is 5 over 9, plus 2/3, times 1 minus that, which is 7 over 9, times 4 over 9, plus 1/3, that's 1 minus that, times 2 over 9, times 4 over 9. So that is all x2, and then x3 is just all of that multiplied together, which is 2 over 3, 2 over 9, 4 over 9, which is equal to, now, all got a common denominator here of 243, 3 to the 5. So that there is 20, plus 7 times 4 times 2 is 56, plus 2 times 4 is 8, plus 2 times 2 times 4 is 16, all over 243. 20 plus 56 is 76, plus 8 is 84, plus 16 equals 100 over 243, which, happily, does not equal a half. So in other words, in this thing, we can safely divide out. And so we can have, I'm going to skip here, 2t equals 1. Hang on, 2x2 plus x3 plus 1 does not equal 0. So 2t equals 1 because of this thing we've got here. And so t equals half. Which is quite nice. So if Priz is guilty half time, then King is right half the time. But that's actually independent of our p-values. I think the only place we used our p-values is to just check that this wasn't a half here. If there had been a half, actually what you'd find is that the king is always right half the time. So this is still true. Which is quite interesting. It's not really the point of the question, but it's quite nice to realise. So actually, you end up doing the second half of this question. We're done now. But without doing lots of horrible multiplying out. Originally, you might think you've got to work out all x0, x1, x2, and x3 and check it all out and add it all up. That's originally what I did. I ended up getting it wrong because I dropped a sign somewhere, etc. Then I was like, come on, there has to be an easier way, because the answer of a half popped out, and I was like, come on, that is so symmetrical, there has to be something here. Actually, yeah, it turned out that there's an easy way. So that's how I've done it. I'll just, yeah. That was quite a nice question, really. And a lot of the probability questions are like this. Actually, if you can see what you're doing and write down, find the right way of writing down the probabilities, actually, it gets very easy because stuff cancels out. It's very easy to write down stuff in a correct but unmanageable way and then get yourself tied up in knots. But if you kind of stop and think, what is the best way of writing this out so that everything's going to cancel out and we're going to have the easiest things to deal with, it makes them a lot easier. But you can really only spot what's going to happen if A, you've done the question, or B, you get the intuition. I think that's what you get by practicing the questions. Anyway, rant over. The answer is t equal to half. T equal to half. Yay. Peace out.